Hello everyone. Today I am going to start a new chapter, chapter 4, and name of this chapter is Properties of Fresh Concrete. This is the outline of this chapter. So let us start first. What is fresh concrete? Fresh concrete, also known as plastic concrete or green concrete. It is a freshly mixed material which can be molded into any shape as per our requirement. So, fresh concrete can be easily molded to a durable structural member. It can be prepared on the spot and may give a wide range of properties from easily available raw material. And the relative quantity of cement, aggregate and water mixed together control the properties of concrete in wet state, that means in the fresh stage, as well as in hardened state. So, next is properties of fresh concrete. Before discussing that, let us know some requirements of fresh concrete, like the mix should be uniform, the mix should be stable, also the mix should be cohesive and sufficiently mobile to be placed in the form around the reinforcement and should be able to cast into the required shape without losing its homogeneity and mobility of fresh concrete. So, these are some requirements. So, let us discuss some properties or main properties of fresh concrete, like first is fluidity or consistency. So, capability of being handled and of flowing into formwork and around any reinforcement with assistance of compacting equipment, and it is the aspect of workability related to the flow characteristics of fresh concrete, and it is an indication of the fluidity or wetness of a mix and is measured by, or we can measure by, slump cone test or simply slump test. And fresh concrete is placed in a metal cone. So, this is the fluidity or consistency. Here are also some factors which affect the consistency or fluidity of fresh concrete, like water content, cement content and its characteristics, plasticity of cement paste, aggregate content and its characteristics, air content, temperature, mixing condition, chemical admixture, etc. So, these are some factors which affect the fluidity of fresh concrete or consistency of fresh concrete. Next is compatibility. So, here air entrapped during mixing and handling should be easily removed by compaction equipment or by using different types of compaction equipment like vibrator for maximum use, or for laboratory any test we can also use stamping rod. So, these are some compaction equipment which you use to remove the entrapped air which is present within this fresh concrete. Next is stability or cohesiveness. So, the fresh concrete should remain homogeneous and uniform. No segregation of cement paste from aggregates, especially from coarse ones or coarser aggregate. So, during the use of fresh concrete, we must have to take care of this some properties like segregation and bleeding, or we have to avoid these things like segregation and bleeding. Again, some major properties like of fresh concrete, like workability, temperature, water cement ratio, segregation, bleeding, plastic shrinkage, setting time, hydration. So, all are very much important individually, very much important. So, let us discuss one by one. First is workability. First is, it is defined as that property of a freshly mixed concrete or mortar which determines the ease and homogeneity with which it can be mixed, placed, compacted and finished without any segregation or separation of the ingredients. And good workability is required to produce concrete that is both economical also high in quality. Each mix must be suitable for its intended use, achieving a balance among required fluidity, strength and economy. And workability is related to the consistency and cohesiveness of the mix and is affected by cement content, aggregates, water content and admixtures, etc. Number 2 is temperature. So, the concrete is not recommended to be placed at a temperature above 40 degrees centigrade without proper precaution. And special problems are encountered in the preparation, also in placement, also in curing of concrete in hot weather. So, we have to take care of it if we prepare any concrete or if we place at a temperature above 40 degrees centigrade. So, we have to take major care, otherwise there is chances of settle down of fresh concrete as soon as it prepares. So, the first 24 to 72 hours after placing fresh concrete are of extreme importance. And in this period, hydration of concrete occurs, which is a chemical process in which concrete gains its strength. So, it is necessary to check the temperature. Next is water cement ratio. The compressive strength decreases in general with increasing water cement ratio and vice versa. But what happens here? If water cement ratio increases, workability of fresh concrete increases, but ultimately strength decreases. Hence, when minimum water is used just to ensure complete hydration of the cement, the resulting concrete will give maximum compressive strength on proper compaction. The next is segregation. The separation of concrete ingredients from each other is known as segregation, and this can be caused due to excessive vibration in concrete mixture machine or falling concrete from more than 1 meter height. And the segregation affects badly to the strength and durability of the structure. Also, segregation occurs due to over vibration or compaction of concrete, in which cement paste comes to the top and aggregates settles at the bottom. Next is bleeding. So, it is defined as the appearance of water on the surface of concrete after it has consolidated but before it is set. Since mixing water is the lightest component of the concrete, this is a special form of segregation also, and it is generally the result of aggregates settling into the mix and releasing their mixing water. It may be reduced, or we may reduce the bleeding of concrete by increasing cement fineness, increasing the rate of hydration and using air entraining admixtures and reducing the water content. We can reduce the bleeding of fresh concrete. The next is plastic shrinkage. So, it happens to the fresh concrete if water is removed from the compacted concrete before it sets. The volume of the concrete is reduced by the amount of water removed, and this volume reduction is called plastic shrinkage. This can be due to excessive loss of water from the concrete due to evaporation, bleeding and soaking by formwork. And this is the shrinkage that the fresh concrete undergoes until it sets completely. It may also be called initial shrinkage. Next is setting of concrete. So, the hardening of concrete before its hydration is known as setting of concrete. The cement properties greatly affect the setting time. Next is hydration in cement. The concrete derives its strength by the hydration of cement particles. The hydration of cement is not a momentary action but a process continuing for a long period of time. If the hydration is to continue, extra water must be added to refill the loss of water on account of absorption or evaporation from the fresh concrete. The desirable conditions are a suitable temperature and sample moisture. So therefore curing can be considered as creation of a favorable environment during the early period for uninterrupted hydration. Next is measurement of workability, or how we can measure the workability of fresh concrete. So to measure, there are some measure or important tests are available, or laboratory tests are available, like slump test or slump cone test, compaction factor test, flow test, VB consistometer test. So these are some tests, some field test or laboratory test which are available to measure the workability of freshly mixed concrete. So first let us discuss, first is slump test. So this is the apparatus, slump cone apparatus, this is the tamping rod, measuring tape. These are some apparatus which we use to continue or to find out the workability by slump cone test. The concrete slump test or slump cone test is the most common test for workability of freshly mixed concrete, which can be performed either at the workplace or at the laboratory. Then the apparatus already I have told, like slump cone, scale for measurement, tamping rod, etc. Next is procedure. So let us discuss this procedure. So for this, the mold for the concrete slump test is a frustum of cone, 300 mm of height, base is 200 mm in diameter, and it has a smaller opening at the top of 100 mm like this as shown here. This is the slump cone. The base is placed on a smooth surface and the container is filled with concrete in 3 layers whose workability is to be tested, and each layer we have to give 25 times tamping with a standard 16 mm diameter steel rod rounded at the end. And when the mold is completely filled with concrete, the top surface is struck off by means of screening and rolling motion of the tamping rod. After that, we have to firmly held against its base during the entire operation so that it could not move due to the pouring of concrete, and this can be done by means of handles. And immediately after filling is completed and the concrete is labeled, the cone is slowly and carefully lifted vertically. We have to lift this cone vertically carefully, and an unsupported concrete will now slump. And the decrease in the height of the center of the slumped concrete is called slump. So we can measure it, or the slump is measured by placing the cone just besides the slump concrete, and the tamping rod is placed over the cone so that it should also come over the area of slumped concrete, and in this way we can measure the slump of this fresh concrete. And again slumps whatever we get after the testing is of 3 types, like collapse slump, shear slump, true slump. These are the figures. Collapse slump, next is shear slump. Collapse slump means in a collapse slump the concrete collapses completely, like as shown in this figure. It will generally mean that the mix is too wet or water cement ratio is more, and that it is a high workability mix for which slump test is not appropriate. Next is shear slump, like this. The top portion of the concrete shears off and slips sideway. If one half of the cone slides down an inclined plane, the slump is said to be a shear slump, like this. So last one is true slump. This is the only slump which is used in various tests. And with this we complete this lecture. In next lecture again we will continue this chapter. Thank you.